All right, welcome. In this video, we're going to be working 2024 AB number 2. And this one's a particle motion problem moving on a straight line. They're going to give us V of t. We're definitely going to be wanting to plug that into the calculator. It looks like I've got something else going on here, probably from the BC exam. So we're just going to clear the RAM and come over here and say, all right, V of t is equal to natural log of t squared minus 4t plus 5. Uh-oh. I must have pressed the wrong button there. Okay, I wanted an X. Okay, evidently X is giving me an arrow now. The other times I had been pressing X on my keyboard, that had not happened. Not sure what the difference is there. Oh, wait, there's more. Now we're going to have minus 0.2. Okay, again, 0.2 x, the differences there. And so we've got there one time when the particle is at rest, which means not moving, means velocity is 0, tr. Okay, so if I'm going to solve an equation, I need to write what equation I'm solving. So I'm going to say v of t equals 0 at tr equals, okay, so we're going to graph the thing. Did it give us a time interval? 0 to 2. So we're going to graph this thing on 0 to 2 and see where the 0 is. Oh, whoops, that's a table. All right, so it's graphing. I see it's approaching 0. There it is hitting it, and I'm just needing to find that time. So I'm going to calculate the 0 between time t equals 1 and time t equals 2. Give it a guess. That'll be tr equals 1.426. Okay. So I've got a response. I found tr. Then it asks when t is between 0 and tr, is the particle moving to the right or to the left? I'm going to say to the right, and like really emphasize that answer of right, because v of t is greater than 0 on that time interval. That's my reason. Positive velocity on the x-axis, that means moving to the right. Okay, part B is going to ask us to find the acceleration of the object at t equals 1.5. Remember, acceleration is the derivative of velocity. So I'm going to say v prime of 1.5 is equal to, I'm going to need to exit out to the main menu and call for a derivative. Math 8 is a derivative with respect to x of y1 at t equals 1.5, and I'm going to get -1. Okay, that's unexpected. Let me go back in here and make sure. Okay, 2x minus 4 over that, minus 0.2. Okay, there must be something going on there, but I'm gonna, maybe I have the graph, and I, just because I'm kind of curious, dy dx at t equals 1.5 is going to be -1. Sure enough. Okay, so equals -1. Okay, and then, okay, I've got a negative acceleration. I feel like I'm thinking about, I was reading something like right before the exam when we were reviewing, and I feel like I read on one of the scoring notes that we needed to say like that this was the acceleration. I don't know that this is necessary. I think it probably depends on the year and on the question and the question leader and all that stuff that's out of our control. But I think the best answer would be a of 1.5 equals the derivative of v at 1.5, which is -1. And then it asks if the speed of the particle is increasing or decreasing at t equals 1.5, and to explain my reasoning. But we can see down here on the graph right here that the y-coordinate of v of t is negative. Okay, so I'm going to say v of 1.5 equals -0.076. That was kind of helpful. You could say or -0.077, doesn't matter. And if you round once, you don't have to round every time. It's either or, doesn't matter. I'm going to say speed is increasing. That's what they asked. Because V and A have the same signs. v of 1.5 less than 0 and a of 1.5, which I already described as being v prime of 1.5, is also less than 0. Okay, and that's going to be my reason. Part C is giving me x of 1 equals negative 3. What's the x-coordinate of the position at time t equals 4? So the integral from 1 to 4 of velocity is going to give me the change in position. So in part C, x of 4 is what we want to know. That's going to equal x of 1 plus the integral from 1 to 4 of velocity. Maybe I'll say x prime, just like the derivative of x, which is going to be velocity. Now they told me x of 1 equals negative 3. So negative 3 plus the integral from 1 to 4 of v of t dt. That's a job for the calculator. So I'm going to quit out to the main menu and say, all right, negative 3, and I need to choose the negative button down here. Otherwise it's going to give me some kind of error. Plus math 9, integral from 1 up to 4 of velocity I programmed into y1 earlier. Oh, whoops. And then with respect to x, let it compute, and then we get negative 2.803. Okay, then part D is going to be find the total distance traveled by the object. Okay, remember total distance is going to be the integral. Okay, they asked for time 1 to time 4. The integral of the absolute value of velocity, the integral of speed. Okay, v of t dt. And so I'm going to ask for math 9, integral from 1 to 4 of the absolute value, math number. Or you can get it, I think it's in one of the F's, maybe F2, I'm not sure. Absolute value of y1 dx, and then that will give me, I have to think about this one, 0.958. Okay, and that's it. That's free response question 2 from 2024 Calculus AB. And yeah, I think that's going to be all for this video. Thanks for watching.